Welcome to the Cow Corporation's series of videos about software engineering. The topic of this video is arrays in C++. Before proceeding, make sure that you have already watched these other videos first. A C++ array that's defined using this syntax will use stack memory to contain its 3 items. You can manually initialize an array. The syntax to do so uses a brace enclosed list of items. An array can be constant. If an array is constant, then you're not allowed to modify the array variable itself, nor any of its items. The items of a constant array must be manually initialized. You are allowed to manually initialize only the first few items in an array. If you do this, then the other 12 items will be automatically initialized to 0. An array doesn't need to be manually initialized at all. So what happens if it isn't? Well, if the array variable has static lifetime, and the items have a primitive type, something like int, then each of the items will be automatically initialized to 0. Or if the item type is an object, then each item will be constructed using the default constructor, and that default constructor will initialize that item. This construction will happen to the items in ascending order. If the array variable is a local variable and the item type is an object, then again, each item will be constructed by using the default constructor in ascending order. But if the uninitialized local array has primitive typed items, then its items will not be automatically initialized, and it would be unsafe to try to use any of those items until after you've assigned some known value to them. You can specify a different constructor for each item in the array. Again, when using this syntax, the array is allocated from stack memory. However, an array could also be dynamically allocated from the heap. When deleting a dynamic allocation that was for an array, use the delete keyword with these extra 2 bracket symbols. When aliasing a type, being an array can be part of that alias. A C++ array is 0-based, which means that its first element is at index 0. So if an array has 100 elements, its last index will be at index 99. You can access the element at index 10 by programming the array's name followed by the number 10 inside of square bracket symbols. It is the programmer's responsibility to ensure that the array actually does have at least 11 elements in its memory allocation. Technically, You're allowed to write this indexing expression the other way around, where it's the number 10 that's on the outside of the bracket symbols. But nobody ever really programs their software this weird way. There are no gaps or alignments within an array's allocation. What that means is, assuming that the type of array elements is int, which each consume 4 bytes in my system, then the memory location of the 10th element will be exactly 40 bytes after the location of the 0th element. An array variable's name refers to the memory location of its first element. In other words, programming with that array variable name is the same as programming the address of operator applied to the 0th element. Furthermore, both arrays and pointers interpret all operators in the exact same way. So, a C++ arrays identifier can be safely cast or coerced into a pointer. Dereferencing that pointer is the same as accessing the 0th element. There are a few subtle differences between an array and a pointer. A pointer's identifier can be reassigned to some other memory address, but an array's identifier cannot be reassigned. A negative array index is never safe. However, negative indexing can be done to a pointer variable if that pointer variable had previously been assigned to be somewhere in the middle of a large enough memory allocation. Here, we show two ways to define and initialize a string. Both are common. Defining it as an array variable allows you to later alter an individual character within the string. But when you define it as a pointer variable, that pointer variable is initially set to be pointing at the compiler's own storage of a string literal. And that string literal is not mutable. Your program could change the pointer variable to point at something else, but it could not change any of the individual characters within that ABC literal. If you were to do double indirection by applying the address of operator to a pointer variable's identifier, then you would get a different number. You get the address of the pointer variable. But applying the address of operator to an array variable's identifier just gets you the same number. It just gets you the array's address. For an array, size of computes the memory used by all elements. But for a pointer, size of always returns 4 on a 32-bit system like Win32. Two elements of the same array can have a pointer difference, which is computed by the subtraction operator. The type of this pointer difference is an int on Win32 and a long on Win64. A multidimensional array stores its elements in row major order. That means this PPI-var array will have 2 rows and 3 columns. The top row is stored first, contiguously, and then the bottom row is stored. Nesting of brace symbols is optional in the initialization of the multidimensional array. Either way, the item at PPIVAR10 will be the item that had value of 4. Any extra trailing comma symbols will be silently ignored. The first dimension's size, the one that's 2 in our examples, it can be omitted if that size can be inferred from measuring the amount of initialization data that was provided. You can dynamically allocate a multidimensional array, but be careful about precedence rules when you do so. These parentheses are necessary. These sizes of 4 and 5 must be either a constant or a literal.